The other day I was looking on the forum and I saw something about getting XYZ data and making a spline from it. So presumably you'd have columns of X, Y, and Z, and you'd want to import that into Onshape and create a spline from it. And there has been something more recently, which is an approximate spline function in FeatureScript. I thought that I would build a FeatureScript powered custom feature using the approximate spline and just see how it goes. So what I want to talk about today is that, and some of the interesting tricks along the way that I've been able to use in order for that to function. So just as a quick demo, you can see it already. It's taking in data, and you can bring in the CSV file, and I've got a few different CSV files loaded up already. You bring it in, and there's a couple of options. You can, firstly, you can not use an approximate. You could just use an interpolated or a fit spline, which makes a spline, a degree 3 spline, that fits exactly through these points, these target points. The new option, of course, was to use an approximated spline, which you can set the degree for, because it doesn't have to be 3, it could be 5 or 7 or something else. And you see some funny things happen when you go to high degree curves, because it starts to try and fit that in interesting ways. This is a pretty random set of data as well, so that makes it a little bit tricky, although it's a good test case for it as well. Anyway, I've got a tolerance in here as well, and you can see as I make the tolerance really loose, the curve becomes smoother, of course, but it then becomes a little bit harder to use. If you're going to use this for a sweep or something in a 3D geometry, then a 3D modeling, then you might want to approximate it and smooth it out. The point is that if you take in 200 points of data, do you really need the spline to go exactly through all 200 points, or are you looking for something a little bit smoother? So you can see here my result is skipping and within tolerance. Some of that, you can see the maximum distance there is 1.9 millimeters. Maximum distance there is 2 and a bit. So we're still within our tolerance of 3 and still getting a nice degree 3 spline through that. So if you want to look at the control points of what we created, then I suggest a custom feature that I just published called the curve evaluate. You can pick that curve, and you can tell that, you can see that it's a degree 3 with a number of spans control points. It's a non-rational one. So you can show those control points here, and optionally or alternatively you can show the knots. They're in black through here and here and here. So this is a fairly sparse, a decent sort of curve for fitting some pretty random data there. Anyway, I've got some other example sets here. I choose sheet number 2, which is, these are all coming from my some random data that I just set up for this, and there's an interesting bad data test at the end. Right, so this one again, we could maybe up the degree to 5 and sort of lower that to something pretty nice like that. I mean, you can see when we up the degree, it does start to get a bit wobbly at the end. So that's the whole point of curve fitting, is to use the simplest curve possible while staying within, here we're in 0.1 tolerance of those. Now I can optionally keep the points. You can see here those points are kept, and we're less than 0.1. That's good. Alternatively, we can turn that off. And here comes one of the first things for the programming of the custom feature. When you do something like that, which is to optionally create or delete points, and during the process of creating the feature, all those points are there because that's how I am rendering those things in red. Typically what you do is you have to keep track of all of these pieces of geometry and then delete them all at the end. Now, people roll their own methods for doing this. You might make an array and keep appending things to an array, and then at the end you do a Q union or something and then delete everything that's in that. Because there's such a regular pattern of doing things like that, and essentially I'm doing the same thing here, but I'm doing it in a really, really neat way. and a method that one of the real developers at Onshape, Josh Newth, has taught me, which is to use a function that is defined in a separate document here. So I'm going to go to that definition and show you what that function looks like. And it's in a separate document because I'm going to reuse the same pattern over and over and over again, and not have to think about re-implementing it each time. So the key to good, clean code and reliable code is to reuse absolutely everything you possibly can once you know that it works, and then use that rather than roll it your own every single time. So here it's a very simple thing. We just create the function called getCleaner, and it handles all of the cleanup within here. There's a couple of methods to it. You can add, you can delete, those sorts of things. So the way that I use that is I import that function up here using this import command. All right, and then down, the first thing I have to do in the body of the code is to create my cleaner object. So I'm just saying its definition, and I'm calling it cleaner, and I instantiate it here. And now, when I want to add something to the cleaning list, I can just do this command here. So I get my definition, add cleaner, which is the object I had before, and then I just do an add, and whatever the object is, the query is, to the objects that I want to delete. So I'm querying for those data points. They were all things created by this routine up here, and then I just say add data point to it. So it's a really, really clean, so to speak, way to do this. And then later on, if there's different objects, different planes or curves or anything else that I'm using for helper geometry, I can just do another add to whatever query it is to that helper geometry. And then right at the end, and based under this little if test here, saying that if I don't want to keep the points, then I'm just going to do a definition cleaner, again that object, and then say that use the delete method on it. So that is all it takes. Now I don't have to worry about those queue unions or doing things in an efficient way with an array append or whatever else, things like it. It's taken care of for me because of this, because we've already done that code a million times before over here. So the cleaner is a really nice way to do things. The other one that I do want to show you, and it's just been published by Josh again, is this one called the report. Now the report is a really, really interesting thing, and you can read all about it, and I'll put links in this description to what the report does and how it's used. It's a little bit of an interesting read as well, because there's sort of two aspects of it. You've got the code that you inject into your own code, and then there's a feature that lets you sort of activate it. Now let me show you how that works. So as Josh said in the video when he made this a couple of days ago, instead of using println everywhere, why don't you clean things up a little bit and use the report? So first thing is to import the Report.fs. Here it is. So it's the custom feature, and you would just do a normal import of it. You would look for the custom feature and import the FeatureScript from the Feature Studio there. So now that's set up for you to use some very special functions. Now let's see the first time that I use it down here. It is going to be here. So dbg is one of the functions, so debug, and there's three sorts of levels. There's a debug, there's an info, which is very similar but slightly different, and warning, right? And I don't think I've used any warnings in here at the moment. But so, for instance, actually the top level one is sort of a harmless thing, an info, and this is where you might say something like the code is beginning, or I'm reading the CSV table data now, right? So that's the sort of thing you might do as a println, or some other comment inside your code. And then what you need to do is in your test Part Studio, before you actually run your custom feature, you actually put a report custom feature. Right? So you put this in first. And when you set that up and you edit it, you'll see that there's a number of different options. You can get it to report all info, warning, debugs, or whatever up here, or turn it off. And you can add specific keys to the reporting that you're going to do. So inside your script here, inside your program, you'll see that some of these are 3-parameter functions and some of them are 2-parameter functions. They can be both. So here, this info, I'm just saying info, first parameter it takes is the context, and then this is the message that I'm going to write to my info, and it will come out in the FeatureScript notices. So this is really interesting because, if I can just look at the FeatureScript notices now, and I think the only one I've got active is my info. Okay, and now you can see it shows you the level of reporting, which is info, info, and info. So only showing me the info things right now. I've been able to filter that by just saying show me only keys from the info level. Right? So it shows me all the keys that were in the info level, and now I've got my reading, I found my data rows, I'm using the approximated spline. This is just interesting stuff for me to know. Now, without going back and deleting those, I can completely change the level of debugging that I'm looking at here just by changing what's in that report function. So I'm going to turn on one here, which is my regex. Now, regex was notoriously difficult to debug, and it's exactly why I want to actually have a debug output. So you see, as I've turned this report feature back on, my FeatureScript notices I've now got a bunch of data all coming at the debug level to do with the regex key. Now I've got lots of different keys within the debug level. I've got things to do with units, things to do with the approximation, and things to do with obviously the regex. So what I'm doing here is just verifying that as I'm going down the data lines that are coming in from the Google Sheet here, or the CSV file, it's actually validating the data. Now it becomes more interesting and more sort of pertinent when you have really bad data. So let's open up some bad data and see what that does. So I'll go back to my XYZ curve fit data feature, and I'm going to bring in or refer to this CSV data, which has got deliberately bad information in it. Now you can see straight away that my regex debug is telling me that it's skipping a row because it's found non-numeric characters, it's found a good row, it's skipped another couple of rows, blah, 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 and it's found, it's got through the rest of the data without crashing. Now this is really, really good because, the regex in here, if you see the match the pattern that I'm using for the match, it's not exactly intuitive, but in the end it's worked quite well. And you can see here when I set up this little loop here, you can see I'm reading in the entries of the data from the CSV, and I'm doing a match on the 3 columns. It's got to have a true match for each of the 3 columns, column 1, column 2, and column 3, or the index 0, 2, 1, 2. And if it passes that, then it means that it's a number, negative or positive number, with decimal or not. And if so, then I'm adding it to my array of positions that I'm going to use for the curve fit. If it doesn't pass that triple check, then it will fail that if check, and it will go and write something to the debug here. You can see how it's debug with a regex key, and it's telling me now I'm skipping because it's found non-numeric characters. So this is really interesting for debugging because I can just keep changing this CSV data and not have to keep inserting, commenting out different print lines that are inside the code. Now that is, what else did I use? Oh yes, there's one more thing that I did use it for, which is the units. So I was playing around with it, I actually did get it to work where I can specify the units which are coming from the source CSV. So if you know that those were in inches, then you can change that. Obviously, it's made it a little bit bigger, so now it's 20 inches across, not 20 millimeters across. And that is indeed checking out. If I look at that in inches, it will be 20 between there. Yes, okay, so that's worked. And in order to do that, I had to create a scaling factor, which I wanted to check here in a units debug. So because of that, let's change that. Let's say, okay, yeah, that's a bit better. It was trying to fit that data with a very, very small tolerance. Because we'd changed the units, I needed to change this. Actually, should change that to, there we go. That's good. So yes, that was another really good use of it, because I can just focus in on the thing I'm trying to debug without having reams and pages of walls of text data. And sometimes if you want to stop that wall of data, in the old days you would go in and comment out a print line, and you'd forget where it was, and it gets very, very messy. So this Report.fs allows you to cleanly add these debug levels or info level or warning level messages into your code. And the great thing is that you can leave it there, because when I want to, and I'm getting close to publishing this, all I have to do is take these reports out of the example, and it's going to work perfectly. And now I'm not going to have any noise in my FeatureScript notices, and the code really doesn't suffer from it at all. In fact, when I come back to it and I want to debug it, I can very, very easily create a new report, put it above the feature here, and get things out of it that way. So to recap, a couple of really useful things is this cleaning routine, this pattern that you can reuse very, very easily and make sure that you have compact and reusable and readable code, because you're not changing it up every time you do it. And this Report.fs, which is a really nice thing that I will definitely provide this link to, that Josh has been writing. So because it's come from a real developer at Onshape, you can know that's useful because he found that useful for his own work, and indeed that's why it exists. So I encourage everybody to go out and have a try, and then start writing cleaner, more readable, and more robust code.